Well, thanks so much for inviting me to give a talk on this paper. This is joint with Kevin May, who's a PhD student at UT Austin. He'll be on the market this year. And he's doing work on open source, which be kind of interesting. If you're interested in that topic, please take a look. So this paper is currently, I'm in the process of revising it. So some of what I say may come out as therapy for the referee process. So keep that in mind. So the motivation, I'm a pessimistic guy, so this is a bit of a pessimistic paper. Cryptocurrency platforms have sparked enormous investor interest. I mean, I looked at a recent Coinbase survey, and 86% of 352 institutional investors are either exposed to crypto or plan to increase their exposure. We can see that BlackRock and Fidelity have huge ETFs, so attracted a lot of interest. In fact, it's like the largest ETF for Fidelity. And I saw on my phone today that S&P has just announced that it's going to create a digital markets index of 35 cryptocurrency industry-related stocks, as well as 15 cryptocurrencies itself. So I kind of want to think about, is this good for the cryptocurrency ecosystem? And I'll give you a precise sense in which I think about that in the next slide or two. So blockchain technologies also enable experimentation of new ideas, whether it be about governance. I have some papers on DAOs and consensus protocols, for instance, looking at that. NFTs, we heard from Sam a bit earlier, and there's some interesting parallels with my paper and his, which I hope maybe you'll see too as we go through it. Decentralized finance, we just learned about AMMs, which is really exciting and interesting. In fact, I'm discussing Ariel's paper in a few days on that topic precisely. So the key novelty to me, and I've been thinking about this for quite a few years, is these crypto platforms are mediated by a retradable currency. And often the conventional wisdom, I say that because this has kind of been the way people have thought about it for over 5-6 years now, is that's kind of a good thing. It's a positive network externality. It subsidizes adoption. There's a canonical paper, Congley and Wan, and I'll come back to, but it's a more general idea. And basically it's this. Imagine there's a marginal guy on the platform. He's not super excited about the technology, but if he gets a bit of an extra return, he's happy to come on the platform. That gets the marginal user on, that improves network effects. And we were thinking in the background that speculation should maybe aid in liquidity provision and in price discovery. And in fact, speculation has been a huge part of the crypto space. If you look at market cap, it's going to be concentrated in stablecoins as well as in exchanges. And my data goes through 2023. We're updating it now. It actually requires a huge scraping process of going through the Ethereum the Ethereum data to be able to sort everything out. But you can see like a huge fraction of it's really just asset management. It's people putting their tokens into asset management, whether it be just to hold for yield farming or to speculate to try to hope to get a return. So conceptual question is like, is this a good thing? How does asset retradability interact with adoption and learning when speculation really represents an outside option to adoption? Does it improve liquidity provision and learning about platform technologies? And does this have any implications for platform design and seniorage policy? And there'll be a sense in which DeFi and all that stuff comes out in the background of what's going on in my talk, and I'll try to make more connections as we go through. So what is this paper? It's a model of a new platform technology of an unknown quality. We're learning about it over time. There could be network effects and the benefits from the technology. There's also going to be network benefits and social learning. The more we do, the more we learn about the technology. And that's going to be an interesting additional force, although not super necessary to everything I have to say today. It's quite a robust channel. Heterogeneous cost. Agents are heterogeneous in the cost of adoption. This is in the network literature seen as a good thing. This is often considered, like by Easley et al., as a positive network externality because it helps to smooth out the adoption curve. So departing from the previous literature, I'm going to think about the option to speculate as introducing rigidity into the adoption decision. It's going to be an incentive compatibility constraint that holds at each instant, whereas the typical literature has thought about it either there are just users that do both, or there are separate entities. There are users and speculators, for instance, in Simon Mayer's market paper, as well as earlier work by Athey. I'm going to think about it, these two types of actors are not necessarily different people. So the key insight is there's going to be a tension between adoption and speculation. Rather than a positive network externality, the retradability is actually a negative network externality. It can lead to rigidity that causes a breakdown on the platform. And this has an implication for optimal platform design in terms of how you want to inflate early on in the life of the platform. I can do a literature review. I'm going to skip in the interest of time, but I've done my homework. So let's get into the model. Time is going to be continuous, the horizon infinite. Platform has an unknown fundamental A with some prior that's going to be normally distributed, nothing innovative about that. At each instant, the platform is going to generate a noisy benefit DDT per token for users that adopt its technology that has a predictable component, pi ta, and a noisy component, sigma d dztd, where dztd is a standard Brownian motion. Importantly, these things are not separately observable. I just observed ddt, so I have to have an inference problem to try to figure out A, and the signal to noise ratio is increasing in the fraction of users that adopt, and that's going to be measured by pi t. So the more we participate today, the stronger is the signal, the more that we learn. It's also going to create convexity. So I'd rather have 50% of users adopt half the days than 25% adopt on all days because of the convexity in learning. This can be viewed as communal consumption. There's a nice management science paper that can microfound why we might think of a benefit looking like this. And those who do not adopt instead just get a much smaller fraction of it. That's not necessary. They can get a totally different fee from it. And you can think of this as DeFi or yield farming, putting my token somewhere else. The key difference just has to be there's a lower expected benefit, a lower EDT in this case, but also less risk. That's the trade-off. It's less risky to speculate, but at the same time, I get a little bit less of the service benefit fee here. Token price is going to be PT, and the total supply is just normalized to 1. And there's an assumption, a background, the platform owner is willing to buy back tokens if there's participation collapse, just to figure out what happens at the boundary. My model has predictions for what happens while there's positive participation, and I need just a refinement what happens after participation stops. This is a small platform, so I'm going to take the risk-free rate to be a constant, or I don't think that's particularly pernicious or important for my discussion. There's going to be a continuum of infinitely lived users. They're going to have local mean variance preferences. This is not at all necessary. The original paper has Kara normal preferences with wealth and hedging demand and everything. Everything goes through. But as part of the revision process we're simplifying, you can get the same idea of just instantaneous mean variance preferences, where my total return is just what I get based on my token holdings XIT, the service benefit DDT, whatever price appreciation there is, and there should be a minus kappa I dt, which represents my flow participation cost, drawn from just some distribution G of kappa I. It doesn't need finite support. In fact, infinite support helps for just showing some things. So it could be log normal in your mind if that's what you think would be reasonable. Because users only observe DDT, they do not observe separately A or DZTD. They have an inference problem. That's a standard common Busey filter. Their mean beliefs or their conditional expectations going to be a martingale because it's a constant. Importantly, you're going to see that the strength of learning is related to that fraction of users that participate pi, and that's going to be reflected in the decline in my uncertainty about A, that d sigma t dt. And as I said, there's convexity. We'd rather learn a lot today, high pi t squared, versus spreading it out over time. So that's going to be an inefficiency that I can kind of talk about as we go through. Equilibrium is kind of standard. Everyone's maximizing rational expectations because it seems pretty reasonable. Token markets are going to clear. Sum of speculator and adopter demand is going to be equal to 1. What does user demand look like? It's going to be standard mean variance. With Kara, it has a hedging preference, and that kind of took a little bit more work to go through. Importantly, there's going to be differences in not only the volatility that they face, the denominators for the adopters and speculators, but in the Sharpe ratio of their trading strategy, where 1 is going to be for adopters, 0 is going to be for speculators. This is going to capture the idea that there's less risk in speculating because I'm less exposed to that service benefit, but also lower expected return from it. And if you want to think about what the Sharpe ratio is, it's the marginal risk to reward ratio. What is the price of risk for participating on the platform? How do users choose to adopt? It's going to be a cutoff strategy. It's quite clear to see the critical value of the adoption cost or the participation cost, kappa star, is the difference in the Sharpe ratio squared between adoption and between speculating. I got the question, what is a Sharpe ratio, as I was revising the paper, so maybe I can make this a bit more interpretable. Kappa star is just the difference in the variance of the strategies. XA star DRT star versus XS for the same marginal adopter. And this kind of tells you the problem here. If there's not enough variation between these two, then it's going to be very hard to support adoption. Kappa star equals 0 will be the only solution. And you might say, well, is this a general idea? I can even make the participation cost pi times kappa so that the cost goes to 0 as fewer users participate. This is still going to happen. You won't be able to find a fixed point with positive adoption. And the idea behind this is kind of a casual observation. Tokens may just be too volatile to actually use. Why would you spend a Bitcoin on buying pizza, the famous example, when it's later, a year later, worth 50 times what you paid the pizza for? Token price is just market clearing. There's the expression over there. The risk compensation is just the harmonic mean of investors' return variance. That's kind of standard. The interesting thing is there's either 0 or 2 equilibrium when pi is positive. We focus on the high one because we're trying to give the best chance for the platform to work. And the necessary condition for adoption is that the expected service benefit divided by the volatility of the service, I call that the adoption information ratio, exceeds the capital gain Sharpe ratio, the expected excess return in absolute value from speculating, divided by sigma pp. And so it tells you the expected benefit has to be higher from adopting than from purely speculating. But it's a bit deeper than that because the left-hand side is something that we know today. This is a static object. Pi a hat is the benefit today from adopting. The right-hand side is a dynamic object. It's about participation in the future. Prices are low today. They're expected to be high tomorrow if participation is high in the future. But expectations of a strong platform today actually compete with usage today. And so it's kind of like a snake eating its own tail. Anticipating this is a strong technology counterintuitively competes with people willing to use it today when it's perhaps perceived to be a bit weaker. Platform stability. There's a cutoff in A star as sigma marches on, such that if A is above that A star cutoff in beliefs, we have participation. Otherwise, a collapse and we just have prices being fixed going forward kind of makes sense. As I said, the more we participate, the more we learn. Well, if there's 0 people using, we don't learn anything. If we don't learn anything, then our beliefs don't change tomorrow. If our beliefs don't change tomorrow, we're stuck in the same place ad infinitum. So once platform participation ceases, we end up with a learning trap and we don't move on. There are 2 benchmarks I can highlight. If participation costs are 0, everyone participates, things are great. If I follow Kong, Lee, and Wang's example, and I don't pick on the paper, I love this paper, that's why I kind of use it as my benchmark. If you can adopt or exit, you don't have the option to separately speculate. There's also always an equilibrium. This is not specific to the choice of network effects. I have a third benchmark as well. Suppose there are users and speculators are a separate, distinct animal. Always in equilibrium, things are great. This is not the fact that there is speculation. It's that users endogenously choose between the two. It is this incentive compatibility driving this result. I can show you this graphically where we're working to make this thing a bit nicer to see, but as you can see on the left panel, as sigma goes up, the uncertainty about the platform fundamental goes up. More uncertainty, more opportunities to speculate about the future behavior of the platform. The higher the critical A is required to get positive participation. And of course, the higher is A conditional on participation, the more people participate. An example that comes to mind that perhaps illustrates this point is the ICP, the Internet Computer Protocol token. So this launched back, around in 2022. Maybe not the best time to launch. This is close to like a bunch of other events that are going on in the crypto space. But essentially, it was a thing that people were super excited about. There was a lot of talk on Reddit and on Discord about potentially going onto this thing. It was meant to be the it was meant to be the Google of the future. You could do all of your search in a decentralized fashion. What happened was there was a lot of volatility on the first few days of trading, and then the thing just collapsed by about 70%. No one knew what happened. In fact, a lot of people accused the developers of doing a rug pull and of doing something malicious. And the developers spent months showing that they had done nothing wrong. It was completely honest. So my paper would explain it as well. There was just too much speculation early on, and that kind of choked the ability to adopt by making prices too high and too volatile for potential users, and that's a self-fulfilling prophecy. Is speculation socially wasteful? Well, if this sounds like a bad idea, shouldn't we ban it? The answer is no, really, because it depends on where you are. For ex-ante weak platforms, yeah, ban it, because you're very close to that breakdown threshold. But if you have ex-ante strong platform, then actually speculation provides a useful service by essentially shorting tokens and letting users be able to participate more and to learn faster. So a social planner would want some speculation because the high participation cost users will never adopt. So it's better for them to just contribute to the platform's social surplus when breakdown risk is low. Finally, for platform design, suppose there's a owner of the platform that can choose optimal seniorage. You're going to get kind of the standard result that the marginal benefit today of selling another token for the price PT trades off against the future continuation value for being able to sell again tomorrow. But the surprising thing is you may want to inflate even more than you would get from like a lack of commitment. The reason being is if you're really worried about breakdown, I would want to make sure that there's such a low return to speculating that no one really wants to speculate early on. That gets positive participation. And then over time, I can buy back tokens if needed to get additional users on by providing that subsidy. But essentially, if I'm really worried about breakdown, I may just want to inflate away to make sure I can erase that part of the parameter or that part of the state space. So we think that's kind of interesting. We do see platforms like Ethereum, for instance, issuing a lot initially, and then deflation comes later when they revise their optimal issuance policy. So just to summarize with 13 or 12 seconds, it's a model of speculation and social learning on cryptocurrency platforms. Speculation can maybe counterintuitively act as a deterrent rather than a subsidy for adoption. Optimal design policy may want to take that into account. And this can be extended in several ways to think about interesting extensions, whether it be DeFi and proof of stake, or thinking about incentive schemes to get users on. And you can imagine with DeFi, there are second uses for these tokens that could precisely create more benefit to speculating rather than using. And with that, thank you so much.
Any questions for Michael?
Yeah, sorry. When a platform is ex-ante productive, high productivity, why is it that this? I imagine some speculators are shorting and some are going long, but you're saying the short effect dominates the long effect, and that's.
Oh, it's symmetric information. So if one speculator is shorting, they're all shorting.
Oh, okay.
Yeah.
So, okay.
Yeah, there's no heterogeneous information here. That's why.
Hi, thanks for the talk. Yeah, I was trying to figure whether there's a connection between your work and works about differential equations that try to capture the adoption of technologies like the BESS model and other models that appeared a couple of decades ago.
Do you have more examples of that? Sorry, I mean.
Yes. In general, I think, these models try to capture the dynamics of early adopters and then people that are influenced by these early adopters and then the late adopters and how this population evolves over time.
Yeah, so those typically would find an S-curve. We don't get an S-curve here. We actually get more of a concave curve in how that happens. So what happens is, like in these curves, there's different phases to adoption. There's a lot really early on that kind of plateaus later. Here, what we find is there can actually be a rigidity for breakdown. That's kind of what we want to emphasize. And that can be actually paradoxically determined based on the future expectations of the platform. Like in other models like Kong, Li, and Wang, and I'll use that because that's my example, if a platform fails, it's because everyone agrees this is a weak technology. A is low. Like this is something we should not have done in the first place. Here, we may actually be killing something that is ex post a very strong platform because expectations kind of get frozen. So I think it's really about, I'm not saying that this is the first model of dynamic adoption. It's really trying to think about how the tension between speculation and adoption affects those curves. So that's kind of how I would say that. But I agree, I'm not the first to ever study the dynamics of adoption through differential equations.
Do you mind if I ask one question?
Sure.
Since you brought up the Fidelity ETFs and we're seeing the rise of these, holding companies like Strategy, can I interpret that as adoption, as speculation in your model, that you're getting access and exposure to the price appreciation without any actual exposure to use the tokens?
Yes.
So does your model actually have strong insights on the consequences of the rise of these companies for crypto adoption more widely?
Yeah. So, I've seen, was refereeing a paper years ago where it's like, oh, it's so great. Look at PayPal and all these other traditional finance venues starting to get into crypto. That's giving a lot of opportunities for people to have access to it. If people are just holding on to it and investing it and viewing it as a vehicle, at some point there has to be the promise of the return. Like this is the future benefit from this. Prices are the future expectation of convenience yields, essentially. It's a mistake people make in housing research all the time. They just look at housing price appreciation. The total return is the convenience yield, the user cost, plus the price appreciation. So the user cost has to come from somewhere. And the point is, if you're moving more toward institutional ownership, it might compete with that. So it might actually be counterproductive. And there was some empirical evidence by Sibelwitz and Wu, like these two researchers up in Michigan, who showed that there was actually a negative correlation between speculation from DEX and like subsequent number of transactions on the platform. It was kind of suggestive, but there seems to be some relationship.
Thank you very much.